let us look at the closure properties of functional dependencies. Closure properties of functional dependencies, and these closure properties are also called as Armstrong's axioms, Armstrong's axioms, or inference rules, or inference rules. Okay, closure properties or Armstrong's axioms or inference rules. Okay, so you can say these closure properties depend. So I'm going to define these closure properties on x, y, and z, which are the set of attributes in relation R. Okay, so let me do this thing. Let me write the formal things which I'm using. So we have given that x, y, and z are set of attributes in relation R, then one can derive several properties from that. Okay, so I'm going to give different functional dependencies on R. So the first closure property is called as reflexivity. The first closure property is reflexivity. So what is reflexivity? If, let us suppose, we have a functional dependency, if you can say x is a superset of y, or you can say y is a subset of x, then x determines y is a functional dependency. The x determine y is a functional dependency. Okay, so here if y is a subset of x, then x determines y is a functional dependency. For example, if I do a, b determines a, it is a trivial functional dependency, and if this is represented by x and this is represented by y, you can see y is a subset of x. That is why this functional dependency always does hold. Okay, so the second closure property is called as augmentation. So what is augmentation? If x determines y is some functional dependency, is a functional dependency, then we can say xz determines yz does hold. So it is a functional dependency. Right? So you can see I just added the attribute y in both the directions here. So I just added attribute z in both the directions, here and here. So that means see, z can also be a set of attributes. So this does hold. So the third property is called as the transitivity. So what is this transitivity property? If we have some functional dependencies like x determines y and we say y determines z, then x determines z also hold. Right? So transitivity again. So I'm saying if sometimes you can see x determines y and y determines z, therefore you can say x determines z does also hold. So this kind of functional dependency, this kind of property is called as transitivity. Okay, then next property is the union property. What is the union property? If x determines y is a functional dependency and y determines, and you can say, and x determines z is a functional dependency, therefore you can union these two functional dependencies and you can say x determines yz. So this is called as a functional dependency. This is called as union property. The next one is the decomposition property. This decomposition property is just an opposite of union property. That means if you have some functional dependency like x determines yz is a functional dependency which is already given, then you can say x should determine y and x should determine z. So x determine y and x determine z, that property does hold. Okay, the next one is called as pseudo transitivity. Pseudo transitivity property. Pseudo transitivity. So what is a pseudo transitivity? If x determines y and wy determines z, then you can say that wx determines z. This will be hold. This will also hold. And the next property is called as the composition property. Composition property. So composition property says if x determines y and z determines w, then xz, then you can say xz determines yz. Xz determines yz. Oh sorry, xz determines yw, not yz. So it is yw. So this property also does hold. Okay, so these are the properties, and using these properties we are going to we use these properties to identify first of all new functional dependencies for a given set of functional dependencies, and secondly we are highly, or you can say we are extensively going to use these properties to find the candidate keys, and you can say roughly in a key in a relation. Okay.